Let's look at problem number 26. Here's some formulas we've been using over the last few days. 26 says a bicycle with a wheel that has a diameter of 27 inches is carrying a cyclist down the road. So the tire's going like this. So how fast would the person on the bicycle be moving if the wheel's spinning this fast? This is a formula we can use. This is a conversion of what we call linear velocity, and we can change it to angular velocity, or we can change angular velocity to linear velocity knowing the radius. So I did not give you the radius here. If the diameter is 27 inches, its radius has got to be 13.5 inches, okay, because that's half of 27. Now the problem with this is it's in inches, so I have to convert it. Inches on the bottom, centimeters on top. For every 1 inch, there's 2.54 centimeters. And this is equal to 34 centimeters. Problem with that is it's still in centimeters. I don't want centimeters, I want meters. So just move this twice and you get rid of the centi. So R is equal to 0.34 meters. Okay, what else do I need to know? In order to know this velocity, I have to have omega. Omega in this case is equal to 2.7 revolutions per second. Again, revolutions, we can't deal with revolutions. In physics, we're always dealing with radians, so we got to get rid of revolutions. We know for every 1 revolution, it goes 6.28 radians. You got to know this. This is the tricky part. This is why this chapter is so hard. It's beyond normal thinking. So revolutions goes away, and we got 17 radians per second. Again, this is the formula we're using. We want to know what the velocity is. Velocity is equal to 17 radians per second times the radius, which is 0.34 meters, and 17 times 0.34. Our answer is 5.78. Let's see what happens here. Radians doesn't really exist. Again, it's not a real unit, so we land up with meters per second. Okay, so that's how you do number 26. Number 27 says, what is the rotational velocity of a wheel on a car traveling down the road at 25 meters per second? The wheel's radius is 25.25 meters. So we have velocity. Now I didn't say angular velocity, I just said velocity is 25 meters per second, and the radius is equal to 0.25 meters. This is standard units, which is good, scientific units. This is 0.25 meters, which is scientific units. And I was asking what is the rotational velocity or angular velocity. There it is. Now I have to rearrange this, and if I rearrange this, I have to divide each side by omega. So V over omega is equal to radius. I'm sorry, that's not what I was looking for. I'm looking for what is the rotational velocity. We divide both sides by R. V over R is equal to omega. So omega, its rotational speed is equal to its linear speed, how fast it's moving in this direction, divided by its radius, is equal to 25 meters per second, or 0.25 is equal to 10, right? 25 divided by 0.25, 100, I'm sorry. 100, and this was meters. Meters cancel. I'm left with something over seconds, and that something we always say is radians. So it's going 100 radians per second.